In the second part of 5.5 with the notes, we're going to talk about the application of this section, and it's going to have to do with way back in chapter 1 when we were doing rotation transformations. So this was the general form of any matrix transformation of an angle theta. So if we take a look at this, but instead of looking at cosine and sine, if we just make it a little bit more generic, A and B, if we find the eigenvalues of this matrix, so if we take A minus lambda, B, A minus lambda, feel free to pause this video and try this on your own if you want to give it a shot. This is going to be minus negative b times b, so plus b squared. This I have simplified to lambda squared minus 2a lambda plus a squared plus b squared. So we want to find a solution for this, and we're going to use the quadratic formula to do that. So lambda is our variable. For the quadratic formula, we have A, B, and C. So I'm going to have lambda equals 2a plus or minus square root of b squared. 2a squared is 4a squared minus 4a c. C is that entire constant, a squared plus b squared, all over 2. Well, 2a, but a is 1. So we have 2a plus or minus square root 4a squared minus 4a squared minus 4b squared. This simplifies to just the square root of negative 4b squared, which simplifies to 2a plus or minus 2i all over 2bi. Let me fix that. And that's going to simplify to a plus or minus bi. So what this tells us is any matrix in this original form, the A minus B, BA, has these for its eigenvalues, A plus or minus BI. So we get to take a very nice shortcut on the next problem. We see that it's in the same form. Here we have 0.1, negative 0.1, 0.1, 0.1. So we have A is 0.1. So A is the number in this spot. B is the number in this spot. So if we know that lambda is going to be A plus or minus BI, we know that for this problem, it's going to be 0.1 plus or minus 0.1i. And that's all we have to do. So what we're going to do is we're going to look at this as some sort of transformation, like back in chapter 1. This, I'm not sure if you've ever had to do this before. If we are plotting an imaginary number, I'm not really sure where this falls, but let's just take 0.1 plus 0.1i. Let's just plot one of them. That doesn't look great. So to plot on an imaginary axis, what we do is we plot A on the horizontal axis and BI on the vertical axis. So if I want to graph 0.1 plus 0.1i, I would go over 0.1 on the horizontal because of the A value being 0.1, and I would go up 0.1 on the vertical axis, which is really like the imaginary axis, and I would plot my point 0.1, 0.1, and I'm going to draw a little vector. So anytime, and I'll just do like a quick little sketch, if I wanted to graph like 4 minus 3i, let's say, I would have a, bi, so I would go over 4 for the real part of the imaginary number, and then I would go down 3. And that would be how I would graph that imaginary vector, or the imaginary number, 4 minus 3i. So we go over 4 on the imaginary and then down 3 on, sorry, I said that backwards. We go over 4 on the real axis, which is horizontal, and then we go down 3 on the imaginary axis, which is vertical. So that, I'm not sure if you ever had to do that before, but let's go back to this problem at hand. So we have this vector. We have 0.1 plus 0.1i, and we have it graphed. We're going to label the angle phi that is formed with the horizontal axis. So that's going to be this angle in here. And then we are going to label r is the magnitude. Magnitude, think pre-calc, think length. R is going to be here. R would be the length of that vector. So if I want to find those two things, so the angle, which is called the argument of lambda, so if I want to find this angle, so if we look at the triangle that's formed here, so if I want to try to figure out what this angle is, I might look at it as, I can do better than that. Maybe, we'll find out. I'm going to look at it as a triangle. A little better. Point one, we don't know, we're going to find r, but we don't know what it is yet. So we need to find r, and we need to find phi. So if I find phi first, so if I know the 0.1 and 0.1, I know adjacent, I know opposite, that means I want to use tangent. So I have tan phi is 0.1 over 0.1, which is just 1. So when I ask where is tangent equal to 1, tangent is equal to 1 at 45 degrees, or pi over 4. So using tangent, if we know the eigenvalue, if we know a and b, we know tangent, and that we can use to find the angle. Sometimes we might have to use our calculator for that. That would be like using the inverse tan button is what's going to give you the angle. To find the magnitude, which is r, I would just use the Pythagorean theorem, or you can notice that it's a 45, 45, 90, and we can find it that way. So if we recognize it's a 45, 45, 90, then we know that r would be 0.1 times root 2, because it goes like x root 2. Or if you didn't notice that, then just r squared is the square root of, oh, I wouldn't say is the square root. R is the square root of 0.1 squared plus 0.1 squared. And you can find r that way. You get the same number, it just might not look the same. So what this signifies, we have this matrix, the original matrix, which you can't see on my video because I'm only showing part of the screen, 0.1, negative 0.1, 0.1, 0.1. So we had this matrix, which was in just the generic form A minus B, B, A. So anything in this form, we can view it as a composition of a rotation and a scaling. So a rotation, think rotation like back in chapter 1, we could use a matrix, we could use matrix multiplication to do these transformations, and that's sort of what we're looking at. This type, anything in this form, is going to be both a rotation. The rotation is going to be this angle that we found, and you can always find that angle is going to be opposite over adjacent, and opposite is B, adjacent is A. And then we can also find the scaling. The scaling, think either a stretch or a shrink, and that's you're going to get by finding the magnitude. So we have a rotation of angle phi, And then we have a scaling, either a stretch or shrink, by this value r, the magnitude of our eigenvalue. So the square root of a squared plus b squared. So anything in this form, a minus b, ba, can be a combination of a rotation and some sort of stretch or shrink.